The staggering number of $1.5 trillion in technical debt is a harsh reality for many companies. 80% of their software budget goes into maintenance. This huge chunk of resources is spent on keeping old systems running. But what if I told you there's a design pattern that can help breathe new life into legacy code? The adapter pattern is a simple yet powerful solution. It acts as a bridge between two incompatible systems. Let's dive deeper into how it works. Imagine working with a legacy system that uses an outdated interface. You need to integrate it with a modern service, but their interfaces don't match. This creates a huge roadblock. The system is also tightly coupled, making it hard to change one part without affecting others. And if you make a small change, the entire system might break. These are common challenges when dealing with legacy code. But there's a way to overcome them. The adapter pattern is a structural design pattern. It allows objects with incompatible interfaces to work together. Think of it like a power adapter that lets you plug a foreign device into a local outlet. The pattern creates a new interface that both systems can understand. This way, you can use the legacy system with modern services without changing its core. Class Modern Service. Def process _ data, self, data. Return data.lower. Class Adapter, Legacy System, Modern Service. Def process _ data, self, data. Return self.process, data. Let's look at a simple example. We have a legacy system that converts data to uppercase. A modern service needs to process data in lowercase. We create an adapter that inherits from both systems and implements a new interface. This adapter translates the legacy system's output into a format the modern service can understand. By using the adapter pattern, you can significantly reduce integration time and maintenance costs. It also makes your system more flexible. You can adapt to changing requirements without overhauling the entire system. Imagine you have an old relational database with a SQL interface. You want to integrate it with a new microservice that uses a NoSQL database and a RESTful API. The adapter pattern can help you bridge this gap. You create an adapter that translates SQL queries into RESTful API calls. This way, the old database can work seamlessly with the new microservice. When implementing the adapter pattern, keep in mind a few best practices. First, keep your adapters simple and focused on one task. Avoid overusing adapters, as this can create complexity. Finally, test your adapters thoroughly to ensure they work correctly. In conclusion, the adapter pattern is a powerful tool for saving legacy code. It simplifies integration with modern systems and improves flexibility. Next video, how to implement clean architecture in your projects. We'll explore another essential design pattern that will help you build robust and maintainable software.